A muscle-up is not only a remarkable display of strength and athleticism, but also a tangible manifestation of fundamental principles of physics. Power is a term usually associated with mechanical engines and electrical motors. It is also used in other devices to produce heat and light. Interestingly, the human body operates under the same physical principles as machines, using power to convert food, energy into heat and work. In this experiment, we aim to determine and explore the power that can be produced by various muscles of the human body by performing various activities. In this experiment, we will use a stopwatch, weights, plyo box, pull-up bars, and a leg press machine. To find power, we must first solve for the force and work. Exerted force is just multiplied by the weight of the performer or an object and the acceleration. Since all of the exercises are performed in the vertical motion, we use gravitational acceleration. For work, the displacement is multiplied by force. Finally, power is work divided by time. To find the displacement and exerted force for this exercise, we measure the distance between the chin and wrist while he is hanging, and the force is the product of the performer's weight and the gravitational acceleration. Same calculation for force with this exercise, and the displacement for this is the vertical distance from the ground to the performer's chest to the maximum stretch of his arm. Same calculation method for force with this exercise, and for the displacement, we measure the distance from the ground up to the foot in the maximum jump. To find the displacement, we measure the distance from the ground up to the foot in the maximum jump, and then we calculate the force applied by including the weight of the performer and the weights as well as the gravitational acceleration. To find the force, calculate the weight being lifted during these exercises, we measure the distance from the performer's feet up to their waist to determine the displacement.
Here is the data representation of the said exercises. As you can see, most exercises have similar results in force.
Here we can observe that various forces, distances, reps, work, time, and power values are given. As noticed, since most of the exercises require lifting your body weight, why is the exerted force in the different exercises the same? Is it because the force needed to lift your body weight is equal to the body weight? This is because of the gravitational force pulling you down. It is the measure of the force needed to counteract gravity and lift an object against the force of gravity. Also, it is clear that the largest force is 597.8 newtons, but it does not result in the largest power output.
As noticed, the 20-second duration listed in the table represents the participant's maximum repetitions for each exercise. This means that the performer was only able to do a particular number of reps in all exercises, in a time frame of 20 seconds respectively. This is also for the performer's stamina to be able to face himself for the whole duration of the experiment.
The rate at which work is completed by power in muscle-up trial, the speed at which work is completed or energy is transported is measured in terms of power. The units of power are expressed in watts. The activity that produces the largest power was jump without weights. It uses leg muscles, including quadriceps, hamstrings, and calf muscles. No, the largest force is not always created by the activity with the greatest force. Power, which measures how quickly work is completed, is influenced by both the force and the speed with force applied. Therefore, even if it uses the largest force at which is applied is low, the power produced can still be relatively small. In a muscle-up experiment, a pulley or lever can speed up the rate at which a person can work by providing a mechanical advantage and lowering the force needed to lift the body weight. In all of these cases, the use of these simple machines allows the person to do work more efficiently, while the machines themselves don't increase the total amount of work done. They do make it easier and quicker to accomplish tasks that would be difficult or time-consuming to do by direct manual labor. we learned directly in our physics experiment about muscle up is how closely connected is the usage of force and the idea of power are. It was interesting to see how even a great force could produce only a tiny amount of power when the motion was slow, emphasizing the need for speed and carrying out tasks effectively.